Hello and welcome to the Academy and the third and final part of Introduction to VAR. In this part, we're going to have a look at the historical method for calculating VAR, the Monte Carlo simulation method, and then finally, we're going to look at something called expected shortfall or conditional VAR, CVAR. And that's when we're going to start to talk about tail risk. So welcome to part three. So the next method we're going to try is the historical simulation of VAR. It's obviously a popular alternative to the parametric method. Again, we're using actual historical returns data that we've got on our tab on our Excel spreadsheet. We're going to estimate VAR from that, but few assumptions about the actual shape of the statistical distribution. So in other words, it doesn't need to be normally distributed. And then what we do, of course, is to look at the ranked order of actual historical losses and identify the level of loss which is exceeded relatively rarely. And once again, we should be using in this example 1% of the time. So that 99% confidence VAR. So we'll use our two ETFs in our portfolio, our 60/40, that simulated portfolio that we've got there. We've got the prices from the previous year, so we're going to use those again, and we're going to look for that 99% VAR number. Okay, now we can use a function on Excel. You see that at the bottom here. It's percentile.inc, and then we'll use the array of data that we have, but I'll show you that right now on Excel. So we see the historical method here. We're using our SPY and, of course, our TLT. So we've got the 60/40 split again here. We're using a portfolio of 1 million. Now, here, another basic element of this Excel spreadsheet is we're assuming every day we are starting with 1 million. It's probably not the case in reality, but what we're doing is rebalancing and always starting every day with the same amount. And that's how we're getting our returns. So what we've got here is we're looking at the data that I showed you earlier on, the data that's on the data tab there. And all we're doing is taking that portfolio value, which again, we're assuming is always the same every day. We're taking the weight of the SPY, that's the 60% in this example, multiplied by that data, and then the weight of TLT multiplied by that data. And that's giving us the returns that we would have got in this scenario. So, you know, on that day, given the moves, the returns on those days for that day for those two ETFs, that's what you're going to get back. Okay. And we've done the same thing, obviously, on that entire column. And they are your returns. So all we've done from that is to say, right, okay, using that 99% confidence interval, we're looking for that 1% significance. We're using, of course, the same Z-score as we've done previously. And that's how we're getting the VAR number. Okay, and we're using, as I suggested to you on the slides, that function on Excel, so percentile.inc, using that data, and then just getting the inverse of the 99% as in the 1%, and that gives us the number of 15,978.52. I've just put on the side here, just for clarity, if we were dealing with a normal trading year, then 99% of that, or rather the 1% of that, I should say, would be 2.52 days. So 2.5 days, roughly in that way. Now, you notice from the method that we've just done, the parametric method, the VAR number is slightly different, but not by a big deal. We're talking about here with the parametric method, 15,727 with a bit of rounding up, where in the historical method, we've got this number coming up here, 15,978.52. And note, the mean return, the expected return that we've used. Previously, we said it was going to be 214 using the parametric method. Historical method is coming in slightly different. But you'd expect that with a slightly different methodologies. And to view all of that graphically, well, the next tab shows us what we need to see here as far as that. So you can see your mean right there in the middle with the light blue line there. We've gone one standard deviation to the left. Remember, we were talking about that 68% when everything's normally distributed. So I'll just put that in there just for clarity. And then we've got our various confidence intervals of 90%, 95%, and 99%. And you can see, obviously, on this graph where the values would lie. So again, it goes back to those numbers that we've seen on the previous tabs. And it's just for a little bit of clarity, just to make everything very obvious. Okay, and so on to the final way we're going to calculate VAR. We're using the Monte Carlo simulation method. Very similar to the historical method. but here we need to simulate a large number of portfolio returns or P&L. And we're doing this over a specified time horizon, then of course, finding the appropriate percentile of distribution. Now, this kind of method is necessary for any instrument where their value is not a similar linear function of a single price. So for things like options, but that's a conversation definitely for another day. What we're going to use is more exotic probability distributions than simply the normal distribution that we've been criticizing up to our point here. So following on from those previous examples anyway, instead of just inputting a z-score, to have a z-score calculated from our confidence interval, we're going to need to generate a random z-score. That's going to be a fairly easy process on Excel, and there's the function you see right there, and we'll use this in a few moments on our Excel spreadsheet, and we're going to have to calculate a scenario var. And that's what we're going to be looking at very, very shortly. Don't worry, if you're unfamiliar with all of this, I'll take you through each of these stages as we do it on the Excel spreadsheet. So we calculate that scenario var, as we're going to call it, and we're going to copy that scenario var to what I'm just going to call a simulation table. Now, the example I'm using uses 10,000 of those simulations. So it's quite a large number here, just to make what we are looking at here more valid. Okay, so 10,000 simulations. Now, what we would then do with those simulations, you'll see me do this on Excel. I'm just telling you the process I'm going to go through. I'm going to grab that entire table of these scenarios, and I'm going to go to the What If Analysis tab. And then when I get in the What If Analysis tab, on one of the cells that I'm going to use, that's this column input cell, I'm just going to pick a random cell on the Excel spreadsheet. So I'm just going to get it, I'm falling it in to give me a random number, okay? And I'm doing it that way. And then, as we've done before, I'm going to calculate the Monte Carlo var. And that would be done using the same function as we've used previously. And to run all of these lovely scenarios, all you have to do, press F9. And I'll show you that again when we do it on the Excel spreadsheet. So let's get there right now. And so once again, we're back to our spreadsheet, and you can see on this Monte Carlo method tab, most of the details have been filled in. We need to fill in a few gaps, and I've got a few things waiting in the background to pop as soon as we fill those gaps in. So remember, we've got our still 60/40 portfolio with its $1 million value. If you look to the left-hand side, obviously we've been using an expected return before on the SPY of 7% and on TLT 3%. And as before, we've worked out our standard deviations. So we have those for both the SPY and TLT, and we also have our covariance. That all translates over to, of course, the portfolio box here, where we talk about our portfolio variance. And that's based, as we've done before, and you can see the same numbers as we've used before, or we've calculated before. And then we need to take that to the portfolio standard deviation. So all we do, once again, take that variance number, take the square root of that, and we've got our standard deviation, again, as we've seen before. So let's move down to this value at risk box now. We are still using a one-day VAR. Remember this number from previous tabs. When we look at this expected return based on the scenario above, based on the data that we have on our data tab, we worked out the expected return was $214. That's our mean return. Now what we're going to do, rather than just have a z-score calculated from the confidence interval, we are going to get Excel to randomize this for us. And we do it exactly like that. So you see the function here, norm.s.imv, and then of course rand in the brackets with the other parentheses in there as well. But I've done the heavy lifting, you don't need to do this. And that's going to give us a random z-score whenever we run this sheet. So every time we press F9. We're going to work out the VAR on that. We'll call it this time a scenario VAR, but it's the same calculations we've seen before. So we're taking the expected return, as you see right here, taking away the portfolio value, multiplied by portfolio standard deviation, z-score, number of days over the trading year, the days in the trading year, and of course we need the square root of that. So we're going to do exactly that. So we equal the expected return minus the portfolio value multiplied by our portfolio standard deviation multiplied by our z-score. This is the one that's been randomly generated for us. Multiply that by the number of days. We're using 1 day here over the 252, roughly the days in the trading year. And we're taking that to the exponent of 0.5. And that's because we need the square root, if you recall from before. And there we have our scenario var. Well, certainly a scenario var based on the number, the z-score that's just come up. I have copied that scenario var over to here in cell C12. So I've got that in there. I've just simply copied it over, and we're going to call that, of course, our scenario var. What I now need Excel to do is to simulate this 10,000 times. So I want it to simulate these numbers 10,000 times. So what I'm going to do, I'm simply going to Control Shift and then down, select this entire simulation table. And as the slide suggests, we go to the Data tab at the top. We go into the What If analysis, go to Data Table. And all I'm going to do in this cell that says column input cell, I'm just going to select any random blank cell on this spreadsheet. For this example, I'm just going to use E11. Okay, it's blank, it's not being used. I would put that in there. And as I press OK, I get these 10,000 scenarios coming up. And each one is based on the randomized z-score that came up when we ran this. And you'll see it keeps changing as we keep running this program. Also, you've seen pop up a little graph that I had prepared in the background, and that is showing you, of course, the scenarios here all displayed nice for us to see in a graphic. So then all we needed to do at the end, and again, it was already there ready for us to go, is to calculate our Monte Carlo var. Okay, but with this, we're simply using the Excel function as we've done before. So we're using that percentile.inc, and then we're taking the array of data, as you see here in column C. That's all of the scenarios, the simulations that we've run here, and it's 1 minus the confidence interval. So all we're saying is, please find the 1 or the first percentile of all of this, and that's going to give us our Monte Carlo var. That's what we're looking for. And sure enough, that's what we get. Now, if you notice, if I keep running this, you'll see the graph change. You'll also see the z-scores change. And of course, the scenario var keeps changing. And it changes, sometimes quite large amounts. But you'll notice the Monte Carlo var doesn't change that much because, of course, what we're looking for is just that 1%. We're just looking for that 1%. So it's the 1% out of all of these 10,000 scenarios. That's not altering very much. Of course, it won't. But the individual scenario var will. And you can see it jumping all over the place as the graph changes. And you can also see the Monte Carlo var number isn't that different from when we calculated var using the historical method, and prior to that, when we did the parametric method. So you can see similar results. Even though the individual scenario vars are jumping all over the place, your Monte Carlo var, because it's just that 1%, it's that first percentile, then that is not changing very much. Okay, and that's a Monte Carlo scenario, a Monte Carlo simulation method for calculating your var. And so by way of summary and just concluding what we're talking about here with these calculations, and we've done several calculations in terms of calculating our var. We've used the parametric method, we've used the historical method, and of course, just now, the Monte Carlo scenario method, but we know the limitations of var. We've spoken about them all the way through, not least the fact that often we have to assume normal distribution, and we know that the markets just don't work that way. Okay, now these VAR calculations that we've been doing tell us absolutely nothing about how large the loss will be if we exceed that VAR number, if we exceed that VAR amount. And some investments have what we call a particularly convex characteristic, which means the losses which exceed the VAR amount can be significantly larger than the VAR number itself. So it's all very well saying we shouldn't lose more than this, within a certain probability bound. But what if we go beyond that? So that's what we've got to think about. An expected shortfall or conditional VAR, CVAR, or tail loss, whatever you want to call it, attempts to quantify this. So in other words, it's a conditional mean. And the result, as you'll see on the Excel spreadsheet when we return there one more time, will always be greater than the VAR number, as it shows the average of losses beyond that VAR threshold. Now, how are we going to do this? How are we going to calculate this? Once again, Excel's got a lovely function to do this. You can see it on the screen right now. I'll show you how we look at it on the Excel spreadsheet. So on this final tab, I'm using 3 years of data this time, not just the 1 year that we've been using previously. So 3 years worth of data on SPY from the ETF data tab. So that's why we had 3 years worth of data on SPY. And from that, as before, I can work out the daily mean. And that's what we've done right here, the daily mean. You can see, of course, the Excel function for this, but we've used it before. This is familiar grounds to us. So I'm just taking the average of that 3 years worth of data, and that's giving me my mean. Now I'm going to call this X bar. You'll notice, if you're a bit of a maths purist here, that when I'm talking about the VAR calculation, I'm using the symbol mu. That would be okay if we had the entire population of data. We don't. So we only have a sample. I'm going to call it X bar. All right. And you'll see that further on as we do the calculation. So please don't sue me for the fact that I've used the symbol mu there. That's as if we had an entire population. But then, of course, we can work out, as we've done before, and we have a sample here. So we're working out our sample standard deviation. And once again, the Excel formula you see right there. So standard deviation.s for sample. And again, we're using that 3 years worth of data. So we've worked out the daily mean, we've worked out the daily standard deviation, and we can also now work out the VAR percentages based on each confidence level. And you can see here just below in this example how it's done. Okay, so what we're looking at here, let's use this confidence level of 99% as we have used throughout. So to calculate the VAR here, the VAR percentage, I'm going to take my mean. We've got it at the top there, of course. And what I'm going to do is I'm going to add to that the Z-score. Remember, the Z-score for the 99% confidence interval is 2.326. And I'm going to multiply that by the standard deviation. So remember, the Z-score is all about how many standard deviations we are from the mean. And, well, we know the standard deviation, and we are 2.326 times that number. So all I'm doing is adding the mean to that result. And again, follow the calculation through there. So there's your mean. And then, of course, we're deducting this Z-score multiplied by the standard deviation. And that gives us the final result of 0.02522. In other words, in percentage terms, it is that 2.522%. And I simply copy down, obviously, through all of those confidence intervals. And that's where we get our numbers from, exactly there. So it probably goes without saying, but just as a way of a recap, we've talked about this, several times over since we've started on this journey of introduction to VAR. But of course, the higher the confidence level, the further out the tail we're going, of course, and the greater the losses. And once again, I've drawn this onto the graph, as you can see on the sheet here. Let's concentrate on this 99%, the 99% VAR level that we're talking about here, the confidence interval. And we need to now think about what goes beyond that line. So everything to the left of that line. Okay, so we're talking about this thing called expected shortfall, which is a measure of all of the average potential losses when we exceed our VAR limits. And in this case, the 99% confidence level, which in turn attempts to make up VAR's shortcomings in capturing the risks of extreme losses, what we refer to as tail risk. But how do we go about calculating those average losses, as in everything to the left of that red line, as we've said? Well, Excel has a function here too. And so if I click on to the cell where we're looking at our expected shortfall, and you can see the Excel formula right there. So what we're doing here is we are saying equals average if, And then, of course, what we have, again, is our daily returns for those 3 years on our SPY. And then our criteria is to find everything that is less than or equal to this var value. So what we put in there is the and symbol, and of course the var for that confidence interval, in this case 99%. And then lastly, again, the average range is going to be our daily returns again. And then when we press enter, of course, what we have is our expected shortfall number. And then again, I can simply copy that down across all of those confidence intervals. You can see it here. The expected shortfall should always be more negative than the var number because it's taken an average of everything less than it. And this is something we should definitely be aware of when we're considering risk. Now, I hope you've enjoyed these recordings and I hope they've helped you understand these principles further. This is something we certainly go far beyond when we do the actual course. So hopefully one day I'll see you there.